This is ground. Now this is a ball that is thrown up. The ball goes up, reaches that particular point where its velocity will be 0 and comes back ground. Time is equal to 6 seconds. That means the time to go up will be equal to 3 seconds and the time taken to come down will be 3 seconds. Okay, so this is always the case. So how much time the ball takes to go up, a ball will take equal time to come down. The time taken to go up is equal to the time taken to come down. Okay, second thing is the velocity while it is going up is equal to the velocity when it reaches down. Okay, but the only difference is this will be negative. Okay, so that means if the initial velocity is x, which is going up, x meter per second, the final velocity will be minus x meter per second, which is coming down. T going up equal to t coming down equal to 3 seconds. Now they want us to calculate deceleration. So deceleration also is 10 meter per second square, that is equal to g. And acceleration is also 10 meter per second square, that is g. Now deceleration is while it is going up and acceleration is while it is coming down. Okay, now what is the total distance covered? So this is the point. Now we have S is equal to UT plus half AT square, or I can write it as H over here and G over here. So that is 0 into 3 plus half into 10 into 3, and this will be 5. So this is 15 meters, and therefore total distance will be 2 into 15, that will be 30 meters. Okay, do you understand that? It took 15 meters to go up and 15 meters to come down. Okay, if they had asked total displacement, then the answer will be 0. Average velocity is total displacement upon time, and total displacement is 0, so the average velocity will be 0. Okay, and now they want us also to plot a graph of velocity and time. Okay, so over here, if you want to find the velocity, I can just do that over here. V is equal to U plus AT, that is 0 plus 10 into 3, that is 30 meter per second. So this is time. This is 1 second, 2 second, 3 second, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. So now if you assume the velocity going up to be positive, so 1, 2, 3, that is 30, and this will be minus 10, minus 20, and minus 30. So the velocity when the ball left the ground, it is 30, then it becomes 20, then it becomes 10, and here it becomes 0 at the third second. So that is what is happening over here. In 3 seconds, the velocity from 30 becomes 0. Now, while it is coming down, it becomes 10, 20, and 30 again. But this was going up, this was coming down. So at 4 seconds, it become minus 10. So at the end of 6 seconds, it will become minus 30. So this is the graph of velocity and time. A racing car is moving with a velocity of 50 meter per second, equal to 50 meter per second. And on applying brakes, it is uniformly retarded and comes to rest. So the final velocity is 0 and the time taken is 20 seconds. So calculate the acceleration. So this is pretty easy. V minus u upon t, and this is 0 minus 50 upon 20. So that is minus 50 upon 20, that is minus 2.5 meter per second square. So that is the acceleration. Fine. So we go to the next question. A car initially at rest picks up a velocity of 72 kilometer per hour. So initially at rest, so u is equal to 0, v is equal to 72 kilometers per hour. So this has to be 5 by 18. So that is 20 meter per second. And it covers a distance of 25 meters. Okay. So s is equal to 25 meters. Now they need acceleration. Now students, we don't have time. So we will use the third equation, that is v square is equal to u square plus 2as. So we have 20 square equal to 0 square plus 2 into a into 25. So this will be 400 is 0 plus 50a. So this will be 400 upon 50. A will be 8 meter per second square. Okay, so now we got acceleration and now we need time. Okay, so we can use any equation now, the first two. So we have v is equal to u plus at. So that is 20 is equal to 0 plus 8 into t. So t will be 20 by 8. So 4 twos are 4 fives are, t will be 2.5 seconds. Okay, any questions ahead? Now we have, a motorbike initially at rest. So